Hello guys, welcome to another beautiful and brilliant experience of the renal physiology series. I'm Charles, streaming live from Port City in Rivers State, Nigeria. Alright, today's module we'll be looking at micturition. We'll do that by looking at the meaning of micturition. Then we shall look at the urinary bladder in details, followed by the phases of micturition, and then we would wrap this up by looking at the micturition reflex. Alright, fantastic. The process by which the urinary bladder empties when it becomes filled up with urine is known as micturition. The bladder stores urine. Urine is formed in the human kidney. After the formation of urine, it is transported to the human bladder for storage. Alright, going forward, the human bladder consists of the body, a neck, the trigone, and the urethra. Above here is the ureter. Just a minute. This part of the bladder is the urethra. Not urethra, ureter. This part of the bladder represents the ureter. Okay, the ureter originates from each kidney. If this is the kidney, it originates from here and it terminates right at the trigone of the human bladder. So the urine formed in the human kidney is transported via the ureter to the bladder for storage. Alright, fantastic. Now the body of the bladder is made up of smooth muscles known as the detrusor muscle. Okay, the detrusor muscles plays a vital role in the feeding and emptying of the bladder. Here is the trigone. The trigone is the terminal point for the ureter. Okay, this is the right and this is the left trigone. And then this part of the human bladder represents the neck. Okay, then the last part of the bladder represents the urethra. The urethra is the structure via which urine passes out to the exterior environment. The urethra. Take note, there is a difference between the ureter and the urethra. The urethra originates from the kidneys and terminates in the bladder. The urethra is the passageway for urine to the external environment. Alright, fantastic. Going forward, the next component of the human bladder is the sphincters. There are two types of sphincters. The first one is known as the internal urethral sphincter, and the other one, external urethral sphincter. Okay, good. Just right here is the location of the internal urethral sphincter, and at the end of the urethra is located the external urethral sphincter. Okay, these two sphincters plays a vital role in micturition. Sphincters usually are tunically contracted, okay, which means they are shut down, and when this happens, the bladder fills with urine. But during emptying of the bladder, the sphincters are flipped opened, just like the valves of the heart. The sphincters also opens and closes to enable the bladder to be filled with urine, or to enable the bladder to empty its contents. Alright, we shall talk more of that as we proceed. The human bladder is innervated by the autonomic nervous system. This system is made up of the sympathetic nervous system and the parasympathetic nervous system. Both sympathetic and parasympathetic nervous system supplies the detrusor muscles of the bladder and the internal urethral sphincter of the bladder. The human bladder is also supplied by the somatic nervous system, in particular the pudendal nerve. This pudendal nerve actually supplies the external urethral sphincter. Okay, good. I take it again. For this autonomic nervous system, they supply the bladder and the internal urethral sphincter, whereas for the somatic nervous system, the pudendal nerve, the major supply is to the external urethral sphincter. Alright, fantastic. Going forward, there are two phases of micturition. The first one is bladder filling, just like you can see on your screen. This bladder is full to capacity. Alright, the next phase of micturition is known as bladder emptying. Diagram 2 represents the emptying of the human bladder. Let's look at them in details, beginning with bladder filling. Alright, good. Bladder filling is a reflex process. It is actually a reflex action. You know, when your bladder gets filled up with urine, you don't know when these processes are occurring or happening in the body. So it is a reflex action. Okay, just the same way the heart beats, you cannot stop the heart from beating. Also, you cannot stop the human bladder from filling up with urine. Alright, so it is a reflex process. It is also controlled majorly by the sympathetic nervous system. Alright, that's the sympathetic wing of the autonomic nervous system. The sympathetic nervous system relaxes the detrusor muscles of the bladder upon stimulation. Alright, it also causes constriction of the sphincters. These are the major roles of the sympathetic nervous system. Alright, now when the detrusor muscles of the bladder relaxes and the sphincters are constricted, it means that the bladder fills to capacity. Okay, bladder emptying. Bladder emptying is a non-reflex process. It is actually under voluntary control. That is why most times if you're in a meeting and you are pressed, you are still capable of holding that urine for some time until that meeting is over. Alright, so this is how we know that bladder emptying is under voluntary control. Good. It is controlled majorly by the parasympathetic wing of the autonomic nervous system. This parasympathetic nerve causes contraction of the muscle and relaxation of the urethral sphincters. When this happens, rain occurs. So the sympathetic nervous system plays a major role in bladder filling, while the parasympathetic nervous system plays a major role in bladder emptying. Alright, fantastic. Going forward, the urinary cycle summarizes the process of bladder filling and emptying. In phase 1, there is filling and storage of the urinary bladder. Now, the detrusor muscles are relaxed and the sphincters of the bladder are constricted. These actions are actually mediated by the sympathetic nervous system. From the diagram, you can see the bladder being filled up with urine. Okay, these are the sphincters. They are all closed, both the internal urethral sphincter and the external urethral sphincters are closed. In phase 2, there is voiding of urine. that is bladder emptying. The detrusor muscles contracts while the sphincters of the bladder are opened. From the diagram, you could see that here the internal urethral sphincter is flipped open. The same thing with the external urethral sphincter. So the sphincters of the bladder are opened to enable urine to be expelled out from the body. Okay. In phase 3, there is termination of voiding and the cycle continues again. Alright, that is the urine or urinary cycle. Okay, going forward. Micturition reflex. Before we dive into micturition reflex, I would like to discuss the reflex arc. Every reflexes have a reflex arc. All reflexes have a reflex arc. The components of the reflex arc include 1. The stimulus. Alright, my pen, this is 1. The stimulus. Every reflex action begins with a stimulus. 2 is the receptor, the afferent nerve. This is number 3. Alright, the next component is the integrating center, number 4. And then the 5th component of a reflex arc is the afferent nerve. I beg your pardon. And then the 6th one is the effector or the effector organ. Finally, there is a response. Alright, so basically a reflex arc has 7 components. 1 is the stimulus, 2 is the receptor, 3 is formed by the afferent nerve, 4 is the integrating center, 5 is the efferent nerve, 6 is the effector organ, and 7 is response, the response. Alright, let's see how this plays out in the micturition reflex. Okay, let's apply the reflex arc to the micturition reflex. For the micturition reflex, it begins with stimulus. The stimulus is the stretching of the bladder. The bladder is stretched when it is filled up with urine. This stimulus activates the receptor. Activation of the receptor would activate the afferent nerve. The afferent nerve of the micturition reflex is formed by the nerve. Alright, the center of micturition by the spinal cord and the cerebral cortex. Okay, good. Now, the efference of the micturition reflex, is formed by the parasympathetic nerve and the pudendal nerve. Okay, the effectors of the micturition reflex are formed by the detrusor muscles and the sphincters. Okay, these 2 components forms the effector of the micturition reflex. Finally, the response is contraction of detrusor muscles and inhibition of the pudendal nerve by stimulus coming from the cerebral cortex. How does this work? Now, stretch of the bladder would activate the mechanoreceptors of the bladder. Activation of the mechanoreceptors would stimulate the afferent nerve, which is formed by the pelvic nerve. This pelvic nerve or the afferent fiber would carry the stimulus to the integrating centers. The integrating centers are formed by the spinal cord and the cerebral cortex. From these integrating centers, efferents are sent to the effector organs. The efferent fibers are formed by parasympathetic nerve and the pudendal nerve. Okay, activation of the parasympathetic nerve would lead to contraction of the detrusor muscles and relaxation of the internal urethral sphincter, whereas The inhibition of pudendal nerve by stimulus coming from the cerebral cortex would lead to opening of the external urethral sphincter. When these responses occur, micturition or urination occurs. The whole of this process is as the micturition reflex. Alright? Fantastic. Okay, we have come to the end of today's section. The quiz for today are 1. Dash nerve causes constriction of the external urethral sphincter. This one is very simple. Even a primary school pupil can answer this. Alright. Number 2. Discuss with diagrams the role of the autonomic and somatic nervous systems in micturition. And finally, write concisely on the physiology of urination. Do these assignments and submit them here for grading and guidance. Alright? Thank you so much for tuning in. Let's do it again tomorrow, same time, same place. I remain your presider and facilitator, the anchor of the renal physiology series. And I'm so glad that you are here. Feel free to ask your questions, and I assure you they will all be attended to. Good night.